Okay, hello YouTubers. This is my review for the Draper Expert digital multimeter, which his reference on the Draper website is 61023. But actually it says that this is a digital auto-ranging automotive analyzer. But of course, all of us know it's just a multimeter with some particular features that could be used very specifically for cars, but otherwise it's a normal multimeter. I should apologize for the very crappy light conditions, but come on, this is my study table, which I'm converting to doing this review. And second, my English, because I'm not a native English speaker, so I will try to speak as clearly as I can. So the functions, what functions does it has? It has like DC voltage, AC voltage, I mean direct current or alternate current voltage, right? It says here. It has DC current and AC current, right? It has a resistance probe. It has temperature probes. It measures resistance. It measures temperature. It measures frequency. It measures also the dual angle, which this is for cars. Okay. It has a duty cycle measurement also. It can check also diodes. I mean, has diode checking. It has a tachometer, which is very essentially that's why I bought it, and it has an audible continuity tester. So let's open what's inside and let's see what we find. Or something else. It supposedly it says that it comes with a battery. It's a PP3 battery. These square batteries we find in the supermarkets, 9 volts. But I bought it from Amazon. It didn't come with the battery, so I had to buy one. And I already put the battery on it. So let's see what's inside of the tachometer, of the multimeter. Okay. Okay. So let's open what's inside. It has four pins or things to open, and on top of it we have the multimeter, right, with a rubber cover, which can be removed, as we will see later. It comes with this board. It came there, I don't know why. It comes with the instructions, right? And I will put a link on the description to the PDF with the instructions, right? And it comes with this paper. This paper says how to remove the rubber cover of the multimeter. It doesn't have anything else, right? And it just says, okay, to access the battery. What does it comes with? I mean, what does the multimeter comes with? It comes with these crocodile pliers, which I find very nice indeed, because the outer shell of it's like rubber, right? It's like plastic rubber. I don't know what's that, but the pliers themselves, I don't know if you can see. They are okay, metallic in the inside, but the outside is plastic, which makes the things really nice. I mean, I like this. So for me, I think it's more safe or something like that. Okay, apart from that, the other part, I mean the part you actually connect to the multimeter, they come with those caps, very nice. So the only thing you have to do is you take them off, and they reveal the inside, which you plug into the multimeter. I mean, like this. So okay. So we have the crocodile clamps, right? The crocodile pliers, right? Then we have an inductive clamp, which I will show you. This inductive clamp is like a plier, right, which you open and close here, right? And actually this is for, I mean, according to the instructions, it's only for the tachometer settings. It's not used for voltage measurements or current measurements, which could be handy. But anyway, it has a sensitivity settings from low, 1 in low, 2, 3, 4, 5 to high, right? Which actually I checked on my motorcycle, and actually where it worked properly to make the tachometer measurement was there in the second lowest, which seems fine. It comes with these two things, and this one didn't come with that, because I assume while you are using one, you can cover the other two. I mean, and we have the probes, right? I mean, this is C certified probes, category number 2 up to 1000 volts, right? But they come with a very nice thing, of course. They come with these caps on the end, but they come with a very handy thing, I think, is this cap here. Look, that everything is isolated. This is isolation category number 3 up to 1000 volts, or category number 4 up to 600 volts. But actually you can take this off, right? And you reveal the more common type of probes, actually, and you can put them in again, right? And it clicks when it enters, so you are sure it won't fall, right? So it's a very nice thing. I just found it. Finally, it comes with this temperature probe, right? This temperature probe is just a normal temperature probe for multimeters, and it's very, very funny. Look, there is one bigger side than the other, slightly bigger, which makes not easy to see, but it actually it's made for matching perfectly into the hole, because if you put it the other way around, it does not enter. So it's quite very, just a temperature probe. So let's see what the multimeter has, okay? Okay, so when we move to the multimeters area, right, we can see that the multimeter has like 3 buttons. One button for the range, one button for holding, and another button for DC or AC settings, right? This is the big normal wheel that the dial that you dial and it turns on or off the different settings of the multimeter, right? And the rubber cover. To be honest, at the beginning I thought the rubber cover was a very nice thing, because maybe if you are measuring something very powerful and for some reason the multimeter explodes in inner components, the rubber cover will isolate you from this explosion, because I don't know if you can see, but it's quite hard. It's quite thick. But as soon as I opened the multimeter, I realized that this was just bulky, and it didn't. The only reason it existed was because it needed, the multimeter needed a place to put the things which you actually use, the stands you actually use to put the multimeter in this position, right? So I find it rather disappointing, to be honest. Because at the beginning one can think, okay, very nice security. Essentially, if it explodes, if the multimeter explodes, it can protect your hands. But as soon as I will reveal, right, all the inner components of the multimeter is facing towards the face of the multimeter, which essentially means if it explodes, it explodes in your face, which is not nice. Okay. Anyway, the only reason I find for that is to hold these two stands, right, and to hold these the probes, right, which you can put this way. It comes with this space here, which you can place this way, where you can put the probes. Oh, sorry. Where you can put the probes this way, right, and they will stay there like forever, right? Okay, I will take off the rubber cover, right? I will try to take it off, right? And actually we will see that I made bad publicity. It came with this very handy stand, so the multimeter can stand by itself. Sorry, and it comes with 2 rubber. This is really rubber mounts, which does not allow the multimeter to slip. Okay, it has 3 screws, right, which you have to unscrew in order to access to the battery compartment and to the fuse compartment. I will open that and I will show you what I believe is one part of the big mistake in design of this multimeter, because essentially it won't have a place to put the, it's not easy to replace the fuses if for some reason you blow them out. Okay, so let's open the multimeter and see what's inside. Okay, so once we unscrew the screws, the three little screws, right, which are not that little to be honest. Okay, you take this one, you take these two, and you take these three, right? You can open the multimeter, right? And you open this way, right? And it has two clamps here, something to hold it, right? To this upper part of the case, and this plastic thing, I guess, this is just a guess, is what I believe is the ground of the multimeter, right? For some reason, why? Because you see this is like metallic, right? And here, I don't know if you can see it properly. There is a spring, right? Which when you put this, right? It touches this metallic part. I mean, metallic plastic thing, right? So as I told you before, the multimeter didn't came with a battery, so I have to buy a battery, right? To put on it, although it was advertised, it came with a battery, so false advertising. I will try to take off the battery, right? In order to show you what I think is a problem of design. Here we open clearly the whole multimeter, right? But do you see any fuse? There is no fuse on the multimeter. And in order to access to the multimeter, here there are 4 screws. But I will assure you, it is just to hold the screen in place. It's nothing related with holding the chip. I mean this chip inside. I mean the card. Chip card into the case, which is the problem. So in order to access to the multimeter, to the two fuses, you have really to make a very, this card, this green card you see here, is attached to the multimeter by the dial, right, which is very interesting. And the dial has I don't know if it's clearly seen, but has like this. It's attached like, I don't know how to say, but and it's hard to show. But I don't know if you see here. It's attached like that. So which means that you cannot take off the multimeter if you don't take this off. What happens is that this is so big that if you take off the multimeter, if you try to take off this green card, right, the board, let's call it, I think it will break the board, or it will damage the circuits in a very fashionable way, which is not nice, because essentially you lose your multimeter. So in order to open that, I had to lime a bit this circular part, right? So it could lift off easily, right? And this is what I said. It's not a nice design, because if you blow a fuse for some reason, you want to access the fuses as easy as you can, because come on, not in multimeters, especially in cheap multimeters like this one, you blow fuses all the time. Not all the time, but okay, you got me. So this is the thing. It's not nice to change the fuses. This is why I think it's not a nice design. Besides of that, you remember the cover? The rubber cover. It was covering this. Came like this in order. To cover like that, which basically means that you are covering this part of the multimeter, which is the part where this part of the multimeter, which is the part where the circuits are not facing. The circuits are facing the face of the multimeter, and the face of the multimeter is facing your face as well. So if it blows, it will blow on your face, and having a not nice face is not something nice. So let me take this off, because actually it's quite difficult, and I will show you the insides of the multimeter. Okay, so I don't know if you see, but what I did was I just took the battery off, right? And I take this a bit easy, right? And now I am taking out the main board of the multimeter, right? Which I'm doing right now. Okay, so what you have is, the dial, the other part of the dial, and that is what I was telling you. I mean, this is the thing that holds actually the multimeter, the board of the multimeter in place. You have really to code it somehow in order to open the board easily. I mean, to access the board easily. When you see the board, you have like a normal beeper, right? And the thing I didn't like was the fact that this is the 10 amperes fuse, and this is a small fuse of 0.5 amperes fuse. So the fuses are really very difficult to get. I mean, when you open the multimeter, if you access the fuses, it's because you accessed everything. I mean, everything is here. Look, this is the temperature probes. This is where you connect the probes. I mean, the normal probes. I mean, and this is the screen, right? So this is what I was telling you. I will pass to. I mean, I will move to assemble again this multimeter, right? You have this. Oh, it fall. Okay. One part of the multimeter fall, right, which is this part here that I don't know if you can see, but it clicks here. Okay, I will fix it. And this is the thing. I mean, yeah, I will open it. I mean, I will assemble again, and I will show it to you what is the multimeter when it's up and running. So check it out. Okay, to be honest, with my big fingers, it took me quite a while to put these pieces again. So I will put the things on the multimeter again, just to show you how it comes. I mean, you just put the multimeter, noticing that the probes should come in those 4 holes, and this is the most. This should be the most important thing, and I will do it. So see you later. So look, I managed to put them. The 4. I mean, come on, it didn't take any time. So you just put it down, right? And you just get sure that the board is in place, like properly. So you try to squeeze it up to the point in which it clicks. You check the screen is aligned, which is not in this case, which is easily done by aligning it, right? And you just proceed to install the cover again and the 3 screws, which I will do now. Okay, so we are again, right? Finally I put it back, everything together, and I will put the multimeter in the rubber cover I showed you before, right? She's quite thick, to be honest. Okay, and okay, it's it's together. Okay, it's put. Okay, so it's there, and I will connect some probes. I mean, I will connect the probes in order to show you. I mean, I will connect the probes in order to show you how the multimeter works, basically. But come on, it's just nothing. You put it in voltage, right? One very nice thing when you take the probes off is that it sounds very funny. I like the sound. Like, look, like, very nice. Okay, and we connect the other probe, right? Or we connect the other probe. The multimeter, and we are there. Okay, so for instance, let's take a battery, right? Let's consider, for instance, the case of a camera battery, Sony camera battery, right? For instance. So you know, if you want to check direct current, right? I had it just charging to see how it's going. This is a lithium-ion, ions of lithium battery. So we know that this battery has like this is the positive, the negative, and the C, right? Which I guess is the ground. So I will just put the battery here. It says, look, it's changing towards microvolts, although nothing is connected, which is quite funny. I mean, it ranges a lot. And let's connect something, right? Maybe it's the fact that I'm full of static, or I don't know. So positive with positive, negative with negative. Give me a second. I will do it soon. Okay, so let's test the battery. One thing I said before that was not right was the fact that when you put the multimeter in degrees, right, A in voltage, it shows some random measurement. But this is very natural, because in order to measure voltage, what the multimeter does is that it sends some small current to the probes in order to determine what is the current. Naturally, if you have a nice multimeter, I mean a working multimeter, if you touch the two probes, this voltage should go to 0, which is the case now. Okay, so we have like a working multimeter for sure. So now let's test the battery, right? And let's see what happens. This is a not charged battery, right? And look what it says. It says that it's 3.82 volts, right? How does it work, the ranging function? Okay, it's just fine. How does it work, the ranging function? I will connect the clamps, pin, to a battery, and I will show you the ranging volts, how it works, the auto ranging of this multimeter. Okay, I don't know if you can see, but I hope you see. What I did now was I just connected a normal battery to the probes of the multimeter in order to show you how the range works, right? So when you press the range, I mean now it's auto range, right? So it says 1.366 volts, which means this battery is quite empty. But if you press the range button, namely this red button, it shows a dot here, which says, come on, I'm not auto ranging now. I'm just ranging according to this measurement. And I mean you can change the ranging, right? So it's just that. I mean, you see there is no point anymore, which means everything's over. And this is too high that there is no reading even. So look, this very nice bar here shows if there is some change in current, which for this case is not necessary. So in order to go back to the auto ranging mode, you just let it press and it goes back again. I mean, the same works for DC voltage, which here it won't work for sure. And the same happens for resistance, which okay, we will test later, or even not test anymore. Continuity testing. I mean, this is very important because continuity is quite important. I mean, you need, if you are checking for cables, you need to touch them directly, and they should be like precise. The multimeter is quite fast, to be honest. You touch it 1, 2, 3, okay, and it goes. But if you touch it like this, look that I mean, this ranging here, it blips, but doesn't even blip the sound doesn't come. So you should stick it at least for 1/4 of a second, and there is a lag of 1/4 of a second, which is not that bad, but okay. But it should be almost immediate. Temperature. Let's see. Actually, it's quite hot here because I put the radiators all on. And let's see how does it go with the temperature. Let's put it to 320 degrees Celsius, right? We have 29, 28.8. Okay, very accurate. But if we move it to 750 centigrades Celsius, it shows 29, 28. Okay. If we move it to Fahrenheit for the Americans, this is 82.7, and I mean up to 320 Fahrenheit, which means more accuracy. and if we change it to higher measurements of temperature, up to 1400 Fahrenheit, it shows 83 Fahrenheit. So one is more accurate than the other, as we can expect, because we are just changing the scale of measurement. Which essentially this means that the temperature is not auto-ranging, because you have to range it. I mean, according to how much accuracy do you want to have. Also, the same happens with the frequency in hertz. We have up to 32 kilohertz, up to 32 megahertz, which should be 3200 hertz, and up to 320 hertz, which is the most accurate. I mean, the smallest one. One very reason for this multimeter, duty cycle, right? Which is basically, if I understand properly, is how much a signal keeps closed or open during a period of time. I mean, a repetitive signal keeps open, which will be very nice later for computing dual angle, because it's the same thing. Essentially, if you have a multimeter, and this is very important. Okay, I will explain that later. Okay, we have the tachometer in revolutions per minute, rotations per minute, which is used with this inductive clamp, which I will say something about that later, and the same thing but multiplied by 10, which gives you a higher measurements for higher order revolutions, rotations, or whatever you want to call them. Resistance is auto-ranging. Look, I mean, this is my finger, right, which is touching the two, and if I press this, I have this. I mean, if I press the bottom of range, right? Look, I'm piercing almost myself, like that. Okay, this is my two fingers, and if I press range again, it changes. It is so high that it doesn't even recognize us. Okay, so continuity is just resistance is auto-ranging. This is the only two things auto-ranging in this machine, in this multimeter. Let's move to show you something. Did I show you the temperature? I mean, look, in centigrades we are 29, 28. I mean, with less accuracy, 29. In Fahrenheit is 83.3.2, and with less accuracy it's just 83. So yeah, just by connecting the temperature probe, which is, you can boil water with that, and you see what's the point of boiling of water. I mean, just for making your high school experiments of your kids. Yeah, I will talk about the clamps later. Okay, so this is the thing I wanted to discuss with you. The fact that does it worth to pay £30 more, which means like $60, $50, $60 more, or €20 more for this multimeter, for these additional settings of revolutions per minute or cycles per minute, and these dual cycles? I mean, I don't think so. Apart from the fact that it comes with this clamp, apart from that, I don't see the reason why. And I will explain you why. Revolutions per minute. It depends which type of engine you are having. If you have a two-stroke engine, your revolutions per minute here won't work, because apparently this is calibrated only for 4-stroke engines, which is not the point. If you have, for some reason, an 8 cycles per second, or a 6-stroke engine, I mean, suppose you have these very exotic engines for any other application, it won't work anyway. And it won't work, but basically because apparently this is only for 4-time engines. But if you instead get one multimeter that can ranges a frequency, I will show you how can you just, and to be honest, I didn't use it that because I didn't even know if it's 2 times engine. If it was used for a 4-stroke engine or for a 2-stroke engine. I discovered it was for a 4-stroke engine, but anyway, I mean it's not even proper. The most current thing, the most accurate thing you can have are the measurements of the hertz. The hertz, which is the frequency measurement, will give you the most accurate picture of it. Why? Because what by definition a hertz, right? A hertz is what it takes a signal. I mean, how many signals you have in 1 minute, right? If you have in 1 second, sorry. So if you have in terms, so you want to have how many signals you have per minute, you have to multiply by 60, which is the number of seconds a minute has, right? So, and now is where the things start to become relevant. Because if you have a 2-stroke engine, right, means that every time that the piston goes up, right, a spark is created, namely a signal is generated, right? So you will have directly this measurement for a 2-stroke engines having 1 single cylinder, or because I am supposing that you are connecting the clamp, this very clamp, right, to the wire that connects all the spark plugs, because normally it's quite difficult to have a 1 single wire for 1 single spark plug, but anyway, so this is the thing. If you have a 1-cylinder engine, or a 2-stroke 1-cylinder engine, or you can have directly the cable that connects to the spark plug, you can use this measurement. Hertz times 60 in a 2-stroke engine will give you the turns per minute, RPMs, that you want to count. Now, if you have a 4-stroke engine, you multiply hertz times 60, right, which is the number of signals you receive in a second, right? But you have to remember that the signals you have in a second of the number of sparks you create in a cycle is you create one in a 4-stroke engine. You create 1 spark every 2 cycles. So you have basically to multiply it by 2. Why? Because if you make a spark, right, your engine, there is explosion and again exhaust, so the engine goes up again, and there is the intake and the exhaust and the compression. So the engine does two turns, right? So this is why you have to multiply by 2, because otherwise you will have a 2-stroke engine. So if you manage to connect this bulky clamp, which is not bulky compared to the other clamps, more fancy, for instance the fluctuants, okay, you will have a very nice measurement of how many turns per minute. For instance, say you got 300 hertz, not even revolutions, because revolution will give you directly will give you directly this thing on 4-stroke engines, but in order to be more accurate, really pinpoint accurate, you use hertz, right? So suppose you use 300, you had 300 hertz per second. So in order to make it per minute, will be 300 times 60, which this is 6. Okay, 1. Okay, which is a lot. Okay, which is 18,000, right? So, and you notice that since you are having a 4-stroke engine, right, you have to multiply it by 2, because every time a spark is done in a 4-stroke engine, the number of turns that have been done were 2. To be honest, I won't explain you how does a 4-stroke engine works, but I hope you got it. So it will be 36,000, revolutions per minute, which is a lot. So more or less you get the idea. You get the idea. If you connect, okay, this is important to say. If you connect this clamp, this very clamp, to the cable that goes directly to the spark plug, right, in the top of the engine, I mean just to the cable. Because if for some reason you have multiple cables, as happens in most motorcycles, and you connect the clamp, suppose this is the clamp, right, then you will be firing, and you have a twin motorcycle, like a Harley Davidson, for instance, a twin cylinder motorcycle, like a Harley Davidson, then you will have two sparks, right, two signals, which is the number of sparks you make in order to create combustion, every 2 cycles, which in this case then you can use this formula. But if you have, for instance, a Ducati, I don't know, with an engine type Testa Stretta, which is those 649 centimeter cubics Ducatis that are messing around there, if you have, and you connect the clamp to the 3 of them, right, then you have to notice that every 2 turns, right, you are making every 2 turns you are having three sparks, right? So if you have, okay, so in this case we have hertz times 60, right, times 2, which is the number of that, because which we need to do it because we are using 4-stroke engines, right? And if you have three sparks, right? 3 sparks, then you have to wait. Give me a second. If you are firing 3 times, then you have to divide it by the number of spark wires you are connecting to the clamp. This is the reason why, because you are firing 3 times per cycle. So you need to divide it by the number of cylinder in the case you are connecting the clamp. This is the clamp to the 3 wires that gives electricity to the 3 spark plugs of the motorcycle. So, or if you have a more natural common inline 4 engine, right, like a Ninja or like an F1 or something like that, then you have to divide by 4, because you divide by the numbers of cables you connected. But in 4-stroke engines you always multiply by 2. In 2-stroke engines you always multiply by 1. And this is the thing. This is how it works. Okay, I have to say that the things I am saying has sense only for full injected vehicles. I mean cars or motorcycle. Why? Because if you have a carburetor car, for instance, the way the sparks are produced are with a mechanical system, which normally it doesn't. I mean, it makes sparks even on the not the compression, but the exhaust part of the cycle of the motorcycle or of the car. So you will have not 2 turns, not 1 spark every two turns, but 1 spark every turn, which changes the mathematics. Okay, so now let me explain you and tell you why I believe, I mean seriously, one doesn't need this clamp. I mean, why you don't really need this clamp, especially if you are using you are buying this only for the clamp, only for reading the tachometer or doing dual angle. Basically, a very simple way to measuring current. Suppose you have your spark plug here, right? So you have your spark plug, okay, and you connect the clamp to the spark plug. Okay, so this is the clamp to the cable that provides electricity to the clamp to the spark plug. So the clamp, what does is in order to provide electricity, what the motorcycle does is that it gives energy to the spark plug. And the energy is so strong that it creates an arc of electricity here, such that it explodes the fuel, right, in the air. So, but this is why it actually, the clamp can read it, because the pulse of electricity is so strong that can pass the insulating material that is insulating the cable that provides electricity, and have a remained electricity that the clamps can read. But if you can avoid half the clamps, or even if you have a cheap multimeter, a really €10 multimeter that reads only frequency, right? The one very nice way to have a clamp like this, but really simple one, is that you take you take a cable, right, and you strip the cable, so you see the metallic part of the cable, right? So suppose this is your cable, and you just strip the metallic part, right, and you connect the cable. You connect one part of the cable here to the positive side, right, and the part you actually strip, right, obviously you need to have a copper side making contact with the multimeter, but anyway, so the other side, which is a strip, which is just barely bare a naked copper, right, you wrap it around the cable that provides the electricity to the spark plug. If you do it, since the electricity provided by the motorcycle is so strong, the multimeter actually can read it. The multimeters can read it, and what happens with the black side? You just connect the black side with the helps. It could be with the helps of the crocodile clamps or whatever, or even the probes. You just touch the negative part of, not the negative, a ground in your motorcycle or in your car, and then you can have the same measurements you have with the clamp. In the case you notice that the measurements are too strong or too related, you just cut the size of how much cable you are wrapping around the cable that provides electricity to the spark plug, and this solves everything. So this is why I believe one doesn't really need a clamp to measuring the revolutions per minute. This is the first thing. I mean, this is okay. Okay, and the other thing, but before, so to wrap it up, a multimeter that gives me turns per minute, revolutions per minute, and that gives me frequency, essentially. A multimeter that gives me frequency does the same than a multimeter that gives me frequency and gives me turns per minute or revolutions per minute, right? So this is the thing. Now, so I don't need turns per minute in the multimeter. You wouldn't need it. Now the other reason why may one buy these multimeters, right, is because they can measure the dual angle depending on the number of cylinders, right? But actually the dual angle is related with the duty cycle. So essentially a multimeter that gives me that could give me duty cycle, right, would give me the same as a multimeter that gives me duty cycle and the dual angle, and I will explain you why. Suppose that you have what is the duty cycle? Suppose you have from 0 to 100%. You have a signal, right? You have a signal that is repeated, right? So what is the duty cycle? Is the time that the signal remains open, right, along a cycle. What does it mean? It means that if there is passing of current half of the time, one half of the time that there is a cycle, means half of the time there is current, half of the time there is no current, right? Means that the duty cycle is the 50%. This is quite obvious. But what is the thing with the dual angle? The dual angle is exactly the same, but measures in degrees, right? So if I have that my signal is 50% of the time, right, means that is 50% of 360. So it will be 50%, right, of 360, right? Which essentially is 180 degrees. But but the thing doesn't stop there, right? Thing doesn't stop there because, and especially because it could depend. For instance, if for this you really need to know your car, you really need what are you connecting. But if you understood the previous explanation of how to measure the turns per minute using the hertz, right? The same explanation could apply here. Suppose that your car, which is an old car, normally you use duty cycle for old cars because modern cars they are fully injected, so it's different. But essentially the thing is that if you do it normally, you in cars, every time there is a cycle, you produce a signal, which is in old cars. This is what normally happens. But what I understand normally happens, right? So in this case, you don't need to multiply by 2 if you have a 4-stroke engine, right? Because even in the times in which the car or the motorcycle is not firing, is not in the explosion part. I mean in the explosion, right? Even in the exhaust part of the cycle of the engine, there is a spark. I mean, in old cars, why is just because design is very difficult to do it one time and not the other. But anyway, the idea is this: if you understood what I said before, you could apply this very same principle to compute the duty cycle. So this is the thing. Normally duty cycle should be like 50 degrees. So it's the only thing you need to do is 50 divided by 360, which I don't know, and will give you some percentage here, which you have to check. I don't know, some percentage. But anyway, thing is this: if you understood what I did it before with the RPMs, and you understand really how does your car works, you can avoid to buying a multimeter that gives you the duty cycle and the dual angle, because seriously you really won't need it. I mean, yeah. So I think this is all my critiques I have with respect to multimeters that comes with clamps and multimeters for cars, because basically things are not always what one expects, and they really charge you a lot more just for a few multiplications that the multimeter does by itself, which especially when you use these clamps for testing a motorcycle or a car, you do it at idle in order to have a really precise and accurate measuring, which is really some value you can multiply ex ante having the thing, so it won't be bad. It won't. I mean, it's not necessary. Now, what I will do is that I will try on my sockets in my apartment to see if this clamp is accurate enough to read voltage, which will be very nice. It will be very interesting measuring voltage with this clamp and current also. So I will use as a test my place basically, and let's see what happens. Okay, now we arrive to a very disappointing moment, because to be honest, I was expecting the clamp, as I have plugged it here to this, to the positive or negative side of my plugs, right, from the apartment I'm living on. Basically it doesn't give any reading of voltage. So apparently the clamp doesn't give readings of voltage. Now, if I just change from voltage to, say, current, right? If I change it to current, and look, I have the highest sensitivity, right? There's no reading given, right? And if for some reason I move it to
even finer, more precise measurement of current. It doesn't change at all. And even more precise, doesn't change at all. So apparently it doesn't work. Maybe I will change, because now I'm taking two cables. Let's see what happens if we take the other two cables. But so far this experiment doesn't work, because actually it's plugged to my fridge, right? Which yeah, sad thing. Okay, now I'm repeating the experiment. If I plug it to the other two cables, right? Because at the beginning I was plugging to this cable, right? And now I'm plugging it to the other two cables. And actually I already repeated just plugging to every one and single cable, and it doesn't work. Basically, just to confirm you, we have nothing, 0.01009 volts. It's almost nothing. And if I change the sensitivity, now look, it's in the highest one, look, it's in the highest sensitivity, right? If I change it to the lowest, okay, I will put it together so you can see what I see. And I will use for first time this. Okay, so if I do this, look, I change it to the lowest, 0.11, very nice. And if I change it to the highest sensitivity, 0.11. So nothing changed. Okay, now if I try to connect it to measure how many amperes, how many current is there, and I need to 10 amperes, and remember it's the highest sensitivity, it doesn't change anything. And if I change the sensitivity to low, nothing happens. I will put it again. Low sensitivity, now I will put, it's just repeating the experiment. So, and let's use a finer measurement, nothing happens. And even finer, nothing happens. So and I have to say, I don't know if you see, but this is direct and current. It doesn't make any distinction. In the finest test sensitivity, right, which is mu A, and high sensitivity in the clamp, nothing changes. So apparently the clamp is just used to nothing, to just being a clamp. And fine. But because seriously, if this would work as a current meter, seriously, it would be a very gain. These clamps that the good ones, the ones that really measure current, are quite expensive. So okay, didn't work, and I just scratched my thing. But anyway, this is in the name of knowledge, so yes, that's a good experiment, and I hope you enjoyed these videos, and thank you very much for seeing that, and see you next time. And if you have any other questions or things, just don't worry don't hesitate on putting in the comment section. Okay, so see you, bye.